Yep.
What was your question?
Have I already asked you what you do for your work?
I don't know if you really had. I work at a juvenile detention center, so I supervise juveniles who have broken the law.
So are you going into like social work, or are you just going?
I want to. I'm doing this so I can apply to the social work program.
Okay. Is
So,
it? I mean, I'm thinking of going that way. I don't know. Is it like a good job to go into, or is it just?
um,
I mean, what?
if you like dealing with people, it is.
Okay. Is it like scary at times, or just?
It can be. I haven't really had a problem, but yeah, it can get stressful.
Cool. All right, part two, right?
Yeah, trying to figure out what the research question would be. I guess which product would assemble faster, or which like assembly procedure is more effective. It's my guess.
Yeah, just like on the last sentence. I want to know if the mean assembly time is different.
Well, that would be, I think that's the null and alternative hypothesis, but the research question you want to find out. I don't know. I'm going to see what the answer key says. Yeah, it wants to know mean time, the wait time different than the wait time before.
Right? Well, we already know it's going to be zero, right? The mu is going to be zero. Well, the null hypothesis is going to be zero.
Um, I'm not sure because it doesn't give us a number. Yeah, zero, and then not equal to zero.
So he pretty much just.
It's not simple random. I know that. I'm not sure. Oh, so yeah, it's in the question itself. It's where it says measures the amount of time of 9 of his workers to complete 100 products, and then he measures the same amount of time for the same workers to complete the other 100 products. That's how we sampled it. Well, that's how we collected the data.
Cool.
Okay, it looks like the mean for the first one is 42.977. The mean for the second one is 41.922. And so it looks like the second one's a little faster.
Sweet.
And then let's see. Looking at percentiles, the bottom one's faster. Once it's high enough, it's not significantly faster, but it's faster. Well, wait. Now, once you get high enough, the pre one gets faster. I'm looking at the histogram for the post one, the post assembly change, and it's weird. It's like really low numbers are high, and then it goes to nothing, and then it goes way back up on the other end. And the other one's more reliable in the middle. So the mean is smaller, but significantly the first one looks better.
Okay.
At least that's what I observed. The test we need to perform is a two-sample t-test, or paired sample, yeah.
And you got that from the question, right?
Because we've got two different sets of means,
Okay.
and that's kind of the chapter that we're working on is two-paired mean t-test sample, whatever. That's what we're doing right now. So that would kind of make sense.
So then the requirements are just if it has a big sample size.
That should be one of them. Imagine there's more than one. Oh yeah, are they met? Yes, because we have more than 30 samples.
Well, we have only 9 samples, right?
Well, no, we had 9 workers, but we had 100 products. Is it? I guess we only do have the 9 samples, one from each worker. So we have less than 30.
So then what?
The answer T says we just need to do a QQ plot to test for normality.
Okay.
So let's look at it. Yeah, and it appears to be normal. So
This is the pre-assembly.
well, either one, they both appear to be normal.
Sweet. Now we gotta find the difference between them.
Yeah. You know how to do that in SPSS?
Yeah. It's where's that? Then you have to find the mean of it, right?
Not for this one, I don't think. Want the test static. So all you have to do, like you do what the book says, that there's another way you can do it. If you go to analysis, and then go to compare means, and then go to paired sample t-test, and then just do the first one for the first variable and the second one for the second variable, and then hit OK. It pulls it up as well.
So you don't have to go through like transform and all that stuff?
No.
Okay. Sounds a lot easier.
Because the t-test is 1.220 is what I got, so I just want to make sure you got the same thing.
You said the t-test? Yeah, 1.220. And the degrees of freedom is 8?
9.
9?
Well, no, yeah, it's n minus 1, so it'd be 8.
You would have to divide. Actually, no, we're going to have to divide that the two-tailed thing, right?
I don't believe so. The answer T says 1.22.
Oh wait.
Because it's a two-tailed test, but it's equal to and not equal to. And so you need both sides.
How much did you get for the two-tailed test? Or
My T-score got 1.220.
where?
And the answer T just didn't put the 0. The answer T says 1.22.
Where did you? Mine says 0.257.
For the T-score?
Oh no, for the zig or the two-tailed test thing. The p-value
What does your p-value say?
0.257.
Mine says 0.86524.
What the?
But the answer T says yours is right. 0.257?
Yeah.
Yeah, that's what the answer T says.
So you don't have when? Maybe I'm getting these mixed up.
Oh, I know what I didn't do. You got the right T-score.
I think you already described this to me, but when do you have to? Oh, never mind. I got it.
Yeah, I'll tell you later. I'm in a group meeting.
Then the p-value is greater than the
Yeah,
sum value.
failed to reject the null.
All right, cool. And if it's less than, do you
Reject the null then.
reject the null? Okay.
So then we had insufficient evidence to prove. I don't even remember how it states it. It's really weird. Yeah. We have insufficient evidence to prove that the mean was different.
Sweet.
Okay, are we ready to start this group quiz?
Yep. So we just put it in formula.
Yeah. Looks like I collected a sample. I think it's funny when it uses your name in the example.
So did you get two?
Yep. We need the probability thing, don't we?
So how would you do number 4?
I'm thinking we have to use the applet.
That's what I did. I put the area is, or is that? No. You only do the middle one, don't you?
0.0403. Well, that can't be right. Yeah, I'm not sure what to do either.
Well, do we only do the right hand side because it's greater?
That's what I did, but I don't think they got the right number because there's like 1.781. That seems really high.
Did you put 0.0403 down at the z-score?
No, I put it as the area. Here we go. I found an equation. But I don't know how they got that number.
What's the equation?
It was p-value equals 1.06 times 10 to the negative 11th power is less than 0.05, which is the level of significance. Because they put the t-score into the normal probability applet.
Mm-hmm.
Number. See, in their example, they're only shading the left tail. So we got 0.0228, but I don't know. I wish they gave us a base formula to work off.
Maybe they just put the. I don't know.
Is this review from last time?
I think that's what. I think that's what they were saying.
Okay, so we know our sample size is 9. Your standard deviation is 3.3. What's D? I forget what that one stands for. Do you remember what the D stands for?
Um, it's like the mean, but it's not. That doesn't really help. But are you on 5?
I'm still on 4, trying to figure it out. What did you figure out for 4? Did you solve it?
I just put the. I mean, I don't know if this is right, but just put the 2 on the z-score, and then just click the greater than, and then got the same thing as you. But
I guess we can go with it and see what happens.
I mean, that's if we. I mean, if we think about it, that's 0.04. I mean, but you also get another answer if you put point 0 or 0.0403 in there too.
Yeah, I don't think it's that one.
I don't think so either.
So out of the 2, that's probably the better bet. Oh, I know what that D stands for. That's the mean of the differences.
In the previous chapters, haven't we had to find the p-value, and there was a formula that we had to use?
It's a possibility.
Doesn't 0 equal to like 0.15 something? I thought that was that was in the reading or something. I don't know.
Not sure. I'm just trying to figure out what D bar is. Still. It didn't really tell you what it means.
Go to, in the reading, go to 3.1 all the way down at the bottom. And it's in the hypothesis test, we will refer to the variable representing the differences as D. We will use this notation throughout the hypothesis test. For example, the true population mean will be labeled mu D, and the sample mean will be labeled D. D with the straight line up on top, whatever you want to call that. So it's just the representing the difference.
What is it? What's difference?
The difference between the two, so like for the examples that they're using, it's the true mean difference in the weights of women who follow the diet prescribed in this study, and the ones who don't.
So just subtract the two means then?
Yeah, so you do x2 minus x1, which is the difference. So, but yet we don't have I guess we only shade the left-hand side, I guess. But on the normal probability applet.
Okay, so for number 5, the mean is 31.025.
How did you, I like copied this down to the thing, but then it told me that I couldn't, like, crap. I couldn't put it into or I couldn't read it because there was something wrong with it. I don't know.
When you copied it, did you copy where it says group 1 into it?
Yeah.
That's why I can't read it, because it's not a number. So delete the group 1 and group 2 on there, and then it should work.
Okay. Yeah, it says string variables are not allowed in this list.
Don't just put the numbers in. Don't try to put a name in there.
I never did.
Oh.
I don't know.
Because I've got it in there, right? And it's working.
You did? Dang it. Maybe it just doesn't like me.
Maybe.
What'd you get for the standard deviation?
6 is 341.157.
Okay.
7 is 0.407. 8,
0.0407?
yeah, 0.407.
Okay.
8 is 0.689.
Okay.
9 is you fail to reject the null. 10, you fail to reject the null as well. And I'm still working on the next one.
Sweet.
Oh, here's what might be wrong. When you input the data, go to variable menu well, variable view, and just made sure
Go to,
it's on numeric and not string.
where'd you go again?
When you're looking at the data table,
Uh-huh.
there's two tabs on the bottom. One says data view, and the other one says variable view.
Oh, okay.
And just make sure when you go to variable view that it says numeric and not string.
Okay, that's why. So how do you know why like it it did that or why it went
Probably
straight?
because you accidentally copied the group names in there, and so it tried to read it as a string with numbers
Uh,
instead of numeric.
that sounds. So 11 would be n, right? You still there? Maybe. Hello? You still there? Maybe.
Sorry about that.
Sweet. You can like get onto the same video chat that we just had.
We're on the same one, I think.
Oh, right on. That's good.
What happened was my computer wasn't plugged in, so my battery just drained out and it just shut off on me.
Oh,
I was like, oh no! So, but I'm back.
sweet. So is your test like? Did it get messed up
No,
or?
it's all still open. Because
Oh,
I
right
didn't
on.
die all the way. My computer goes into this like shut off sleep mode, so that
Oh,
way it doesn't like lose everything. Okay, so
so 11 would be the n would be greater, right?
yeah,
Because EF is n minus 1.
12 I got 0.001 for the p-value.
And you got that from, let me see.
When you run the test,
Yeah.
you just made sure.
So I did the pair sample test and it went out to a 0.003.
Did you make sure you changed the level of significance?
Uh, no.
Yeah, even I just ran the paired samples test and it gave me 0.001 on mine. When I just went to analyze and then pair means, paired sample t-test, and it gave me the right one. And then are you still there or did I lose you?
What the heck happened?
I didn't even know that you left because it still says you're in here.
Oh, what the heck?
I have no idea.
Huh. All right, well,
So 12 I got 0.01, 13 you reject the null, 14 to decrease, 15 to reject the null, and we don't have enough information for number 16.
Alright.
Yeah, that's really weird. Okay, next time I'll make sure my computer's plugged in, so we won't have this problem.
What'd you get for 7 and 8?
Let me look. 7, I got 0.407, and 8, I got 0.689.
Oh. Cool. Right on.
Let's see how we did. Did you get number 4 right?
No, I got that one wrong, and I also got number.
Which one? What's the other one you got wrong? I keep losing you.
I know, I did it again. My computer does not like me today.
I've got like 3 pictures of you on my screen.
I got 7 and 8 wrong. I just put them in wrong. So.
Oh, okay.
But yeah, I got 4 wrong too. So probably just ask them about it. I think it did it again. Oh no.
Nope, you're still there.
Sweet.
Okay, well, I'll get this posted and hopefully it's not too weird of a video.
Okay. I'll talk to you later.
Okay.
Yeah, bye.
Bye.